We're going to try to do variation of parameters for things that look like p0 of y double prime plus p1, sorry, p naught of x y double prime plus p1 of x y prime plus p2, that should be of x, Joe, p2 of x y equals f of x. So, first things first, you'll classify this for me?
Second order.
Good.
Non-constant.
Second order. Is this linear or not?
It's linear. It's
Maybe.
non-linear.
No. Is this linear or not?
Yes.
Yes. This is linear. You have function of x, y double prime, function of x, y prime, function of x, y is function of x. Good. It's linear, non-homogeneous ODE. Twalmhode.
Non-constant.
Yeah, and specifically the coefficients in this case, like, are probably not constants, right? But this doesn't
I suppose
exclude
it
the
could be.
constant case,
Yeah.
right?
Are they
So we'll just do this all the
numbers or
time.
functions?
So,
Yes. Right.
could be either, right? Because a number can be a function.
Yeah.
So this covers the Twackle-Chode case, right? But doesn't necessarily only exist in that case, right? So this is a little bit more general. You guys don't actually know how to find the homogeneous solutions to anything other than constant coefficients right now. I'm going to teach you one more trick today. But basically, for us right now, I'm going to assume that either these are constant or I can magic up two homogeneous solutions. Just good with that?
Magic.
So the magic might wait, but
Magic.
I'm going to assume that we have a y homogeneous that looks like C1 y1 plus C2 y2. And really, I guess I should put some kind of h's on those. I'm going to put that as yh1 and yh2. Right, so you found two linearly independent homogeneous solutions with Li yh1 yh2. So they're linearly independent, right? So this is actually all of the homogeneous solution. Like you went and found the general homogeneous solution. You guys all look good with that? So if we start there, then what we need is a way to run variation of parameters. So how does variation of parameters work in the first order case?
Magic. Take a guess.
Good. What do you guess?
Y equals e to the negative. U of x.
Wait. So in the first order case, right? I'd have y homogeneous is, I don't know, something. A times, this is crappy notation, right? Because really it's just, yo, you found the homogeneous solution, it looks like this. Right? And then what do you guess? You guess
Y is u of x.
y is some function u of x times
Y homogeneous.
y homogeneous. Right? So I'm going to do roughly the same thing. I'm going to take the constant, turn it into a function. Now the issue with that is that from here,
It could be different functions.
when you're like, alright, we're going to guess, right? Yeah, they might be different functions. You guys see that? There's two constants, you're going to have to turn it into two
Yes.
functions.
Variations.
Yeah, so you're going to get some kind of system of equations, and it's going to be messy unless you make some assumptions. So you got y1, and the first homogeneous solution, or sorry, a u1 and a u2 and a second homogeneous solution.
But not a third. Oh yeah, why don't, sorry.
So this is me just literally being like, I'm going to turn the c's into u's and pretend that they're functions.
Okay. And then differentiate twice?
Yeah, so then the differentiate twice is where everything gets to be a giant disaster, right? Because you're like, alright, so y prime then is going to be a, oh, you see what I need here?
8 product rules in the
I
end.
need 2 product rules here, right? And then in the next step I'm going to need 2 product rules per term for a total of 10, I think. 8 in this step and 2 in this step. Right, so we're going to make an assumption to simplify our lives a little bit.
Aw.
But,
So the first thing I'm going to do is differentiate. I'm going to say I got u1 yh1 prime plus u1 prime yh1. That's my first product rule. And my second product rule is going to be u2 prime yh2 plus u2 yh2 prime. And I know I did those in opposite order.
is that for a reason?
Yeah. That's because one of the things I'm going to do is just to make my life easier, I'm going to assume that this piece here is 0.
That sounds like a pretty heavy assumption.
Yeah.
Is that because it's usually stuff that cancels out, or
Is this
is it
just
just
That's really just that I went a little overboard by assuming that there would be 2 functions. Right? So I have a little wiggle room, and I'm going to use it here.
Wait, why is that overboard?
Basically because there would be kind of an arbitrary constant in each piece, right?
Okay.
But I don't need both of them, because that's all homogeneous solution anyway. So there's a little bit too much here. I'm going to grab this stuff and just assume this is 0, and you can trust me that this is an appropriate use of wiggle room.
could you does it have to be those two, or can you flip flop?
There's a good reason to want it to be these two, and it's what are you doing next?
Differentiating.
Yeah, the next thing you're going to do is differentiate.
You would keep it with the y.
So the reason I want to keep it with the y's is I know stuff about y double prime, right? I don't know anything about u double prime. And my worst nightmare would be to take my second order differential equation that I have to solve and turn it into 2 second order differential equations that I have to solve,
Work bomb yourself with math.
right? So I don't want this to devolve into solving an arbitrary number of equations. So I'm going to take the part that would make a second order equation and assume it's 0. And if I run into a problem, then maybe I would back out of that assumption later. But you'll see that you won't ever run into a problem.
Ever? Maybe.
Not applying this technique. This technique actually works.
Variations of brain.
This technique actually works. That's what's being taught.
Yeah. So then your y double prime, right, would be, and now you need the product rule, and you're going to have how many terms?
4.
4. Good. So
Can we put them in the right order this time?
yeah, and you can do them in the right order this time. So you can do u1 prime yh1 prime plus u1 yh1 double prime. And then I don't need to do anything with the blue stuff because I assumed that shit was 0. And I'm doing plus u2 prime yh2 prime plus uyh2 double prime.
You
u2 yh2 double prime. Okay, so standing things that I assumed. So I have my assumption y is u1 yh1 plus u2 yh2. Pretty good with that? That was my initial guess that I made. And then what else did I assume here?
That section 0.
Yeah, I assumed the blue thing. So I'm going to write that down. So I got u1 prime yh1 plus u2 prime yh2 is 0. You guys good with that? And now the reason I'm writing that down over here is that I have to plug all this junk into
Original equation.
the original equation. So hold on to your seats. So I'm going to dump the blue thing that I assumed was 0. Scoot this guy over.
Maybe more than the width of my paper.
Yeah, so on this one, I do advise, I'm going to have some stuff over here, so I'm going to have 3 lines. I would advise that you just memorize those as variation of parameters. If you try to do this every time, a product rule is going to get jacked up and it's going to get bad.
Right. And your hand's gonna get real tired.
Yeah, and you'll be at this stage in the test right away.
Exactly, like a cat with
Work.
tape on its paw.
Yeah. Alright, so I'm going to shove all this junk in there. So I have P0 times U1 prime YH1 prime plus U1 YH1 double prime plus U2 prime YH2 prime plus U2 YH2 double prime. Look, right?
Oh, what?
Plus P1, and then there I've got a U1 YH1 prime plus a U2 YH2 prime.
Kids too much for things they solve for what?
According to Ogden, this would just be like simple algebra.
Plus
It's a common differential equation.
P2, and then P2 is times Y. So I got a U1 YH1 plus U2 YH2. And this is all supposed to be f of x. Dude, check that out. Exactly the right amount of space.
I'm not having that luck.
Alright, and then you can go through and cancel some stuff.
Hold on, I wanna do it with you, so.
Okay, I'll give you a second. I was all excited that I was going to get to cancel some stuff.
Hold it.
Oh,
Wait a second.
Keep going, Joe, just keep going.
No way. Jumping jacks and cowboy boots is not a thing.
Anything in boots is not.
Walk, field,
Working?
full cattle is.
Kicking stuff?
Someone with
I do
a dash
enjoy a
pad
good pair
or
of boots for
something
kicking
you.
stuff.
Just now.
Like
Nice.
asses.
Dude.
I prefer to kick ass in my boots.
Alright, you guys all caught up?
Yeah.
Okay, so remember that YH1 solved the homogeneous version, right? You guys with me?
I believe you.
So if you plug YH1 into here, 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 you get 0 out. So notice there's here a P0 U1 YH1 double prime. That looks like the first term with an extra U1.
That doesn't matter because it's zero. Well, that's-
Then here is what looks like the second term with a U1 on it. And here is what looks like the third term with a U1 on it. You guys with me? So those three together add to 0.
Right, and they're already.
Why do they add to 0?
Because they're the homogeneous solution.
Because YH1 was a homogeneous solution. So those guys are out. Out, out, out.
I have to find those.
Okay, next. Look for the YH2s that do the same thing.
Oh.
So here's a YH2 double prime. That one's got an extra U2, but it's got a P0 on it. Here's a YH2 prime. It's got a P1 on it. Cool. It's got an extra Y or an extra U2 as well. So I should use a different, go like this. And here is an extra U2 and a YH2 and a P2. So those three add to 0.
That's a lot of stuff that cancels.
Oh yeah, so this whole term,
Those,
Right?
those terms.
that whole term cancels, this whole term cancels, and you're left with something pretty chill.
I feel like it's a red flag.
Why? Because variation of parameters, remember there's always a bunch of shit that cancels. Right? And it was way more stuff this time, but the reason it was way more stuff is I had 2 derivatives. Right? So there were gonna be 3 terms that went away. for each solution. So what you're left with in the end is a P0 times U1 prime YH1 prime plus U2 prime YH2 prime equals f of x. And really that's P naught of x, right?
Sure.
Okay, so when you're doing variation of parameters, the three things you need to write down are your guess, the thing you assumed was 0, and this third thing, which is u1 prime yh1 prime plus u2 prime yh2 prime is, and that needs to be the non-homogeneous part divided by the first coefficient. So f of x over p of x.
P naught.
P, thank you. And that's the, you need to remember that this is the leading term. Leading, i.e. y double prime coefficient. I don't really remember that, I don't need you to remember that I called it P0. I just need to remember, I need you to remember that it was the thing on y double prime. The alternative to this is you can, if you start with one where the coefficient on y double prime is 1, right, if you divide through by that p naught of x all the time, you don't need to remember that thing's there. Does that make sense? So it'll, after you divide, right, it'll be f of x over p naught. So some students find that to be an easier way to do this. They just remember, every time you start variation of parameters, you divide through by p naught, and then this is just the forcing. Or just when you're dealing with a spring. Is all good with us?
Can we go back a few steps to
Yeah.
the slashing?
Yep. So, where'd I lose you?
Like when you, so we got that thing as 0 because you assumed it was 0, that thing on your left side.
This guy?
Yes,
Yep, so I assumed that was 0.
okay.
That was because I had some slack. Now I've used up my slack, and the rest of it's just because YH1 and YH2 are homogeneous solutions.
Okay.
So what that means is that I know that P0 of x, YH1 double prime, plus P1 of x, YH1 prime, plus P2 of x, YH1 is 0. Like, I know this because YH1 was a homogeneous solution. And then, because I know this, I know that if I slap a function u1 onto all of those, that it's still true.
Okay.
So you're slapping you one
So
on the other
anytime
side.
you see, you would see just a U homogeneous anything, you would know that, hey, that equals 0 anyway.
So what I'm doing is I'm like, alright, this part times P0 is this guy, and this part times P1 is that middle term, and this part times P2 is that third term.
Okay.
So I know those are canceling because all three of them together make the homogeneous version of my differential equation, and YH1 solves that.
So when you do that twice.
Yeah,
Because
but again, I wouldn't advise you guys to actually do this every time, because all the product rules make for serious, like, almost guarantee of error, right? There's like 6 product rules here. So I would advise for
Only.
remembering this set of things, just like variation of parameters for second order linear non-homogeneous ODEs looks like this. Just boom, do this. And if it's homogeneous, you don't need to do this because then there's no particular solution anyway. Right?
Yeah.
Do you guys want to see one of these?
Real quick.
I promise it's not actually hard.
Wait.
Did you have a question?
Yeah.
What?
Sorry.
How do we solve for U?
Good. just like in variation of parameters in the kind of first order case, you're gonna get an equation for u primes.
And then you would normally.
So you're gonna
use-
get a couple equations here, right?
That's what we have to use as our system of equations?
Yeah, and this is gonna be a system of
Oh my
equations,
God.
and the book goes through a whole like,
Okay.
this is a method to do that. And then in the margin, they say, but actually it's just easier to get these two equations and then solve them, and that's what I think. So get these, and then these you can solve, it's not actually hard. Usually you can figure out what YH1, or what, sorry, you're gonna know YH1 and YH2. So you figure out what U1 prime is in terms of U2 prime, sub that in here, that'll get you an equation for U2 prime, integrate,
Can we just provide the closed form in the result?
yeah. You could, it's in a book, or feel free, like, it's not hard, it's just a mess. I don't feel like memorizing it, I just like memorizing the two things instead of 30, but. What was your question, Matt?
Should our spider senses be tingling when we see that thing that's not the top, but close to it, on the right? That bracket right there,
Uh-huh.
and then we just say, hey, multiplied by, instead of actually a function of.
Oh, times P of X, P naught? P naught's really a function of X multiplied by this crap, right?
Okay, more sense. Cool.
Sorry, that was just abusive notation on my part.
Okay.
I dropped the of X's all through there, cause I'm a bad human being.
So, for an example, can we not say that that part is actually zero because well, why can you just say that that one part that we canceled in y prime just is zero? Like, I still don't.
So if you
By that.
run with it not being zero, right?
Mhm.
I'm happy to do that, not up here. Well, I mean, I am gonna do it out of whiteboard though, cause it's huge. If you run with it not being zero, what you'll find is that you have this system of equations, and it's just more stuff than you need, it's underdetermined. And so you're gonna get to make some assumption. What that assumption exactly is kind of up to you. I would advise for the assumption that the book makes, because that makes this step easier. But you can run through it, like you can do variation of parameters not assuming that middle thing is zero. You're just gonna get way more equation than you need.
So will you get like more equations in your system of equations?
No, you'll get fewer equations.
Oh, and then you need to just like kind of parameterize it and,
Yeah, you'd get an,
oh,
right, this is a little bit like that. Okay, so
oh, okay.
in the end, you'd get one equation, right?
Mhm.
And it's gonna have four unknowns in it. And the unknowns are a little bit related, so it's not really fair to say that they're unknown, but there's gonna be four things you need to find. They're gonna be U2 double prime, U1 double prime, U1 prime, and U2 prime. But you only have one equation. You have four variables, so you're like, that's way underdetermined. I get to pick some stuff, I guess?
Free variables.
But if you're given like some initial conditions and then you've already made these assumptions, how do you know that that's actually right? Like, that just doesn't seem okay.
Frankly, you're gonna check it every time.
Okay.
Like, the place that you would notice if this assumption didn't work is you would get some equations like this and you wouldn't be able to solve it. But it just wouldn't work. And then you'd have to be like, oh shit, that assumption was bad, I'll go back.
Redo it.
Or
Right.
it'd be like, oh, that sucks, we
But it won't happen. If
Okay.
it does happen, the correct response would be to say, woo, I found a counterexample to variation of parameters.
won't.
Right, and then publish a textbook.
Oh gosh.